Welcome friends. Welcome to the channel UPSC Maths. So we have finished with the topics graphical method, formulation of linear programming problem, generalizing linear programming problem in canonical form and in standard form. Let's now start with the topic analytical method, also called as trial error method. Since graphical method cannot be applied to solve linear programming problem involving more than two variables, we can use analytical method in such cases. We can also solve linear programming problem involving two variables using analytical method. Let's solve a sum to understand the method. So we have to maximize z is equal to 3x1 plus 4x2 subject to constraints x1 plus x2 less than equal to 450, 2x1 plus x2 less than equal to 600 where x1 and x2 both are greater than equal to 0. Let's start with the solution. So we have to express the given problem in standard form. Since both the constraints are less than equal to type, we have to add slack variable to the left hand side of each constraint. So we get maximize z is equal to 3x1 plus 4x2 subject to constraints x1 plus x2 plus s1 equal to 450, 2x1 plus x2 plus s2 equal to 600, where x1, x2, s1, s2 all are greater than equal to 0. Now we have to find the number of basic solution. For that we have number of variables for x1, x2, s1 and s2. Number of constraints 2, x1 plus x2 less than equal to 450 and 2x1 plus x2 less than equal to 600. Hence, number of basic solution is given by 4c2, which is 6. Now we have to formulate a table like this. Since the difference between number of variable and number of constraint is 2, we have to set two variables equal to 0 at a time. Let x1 and x2 be the basic variables and hence s1 and s2 becomes the non-basic variables. Now put non-basic variables equal to 0 in the given equation. So we get two equations as x1 plus x2 equal to 450 and 2x1 plus x2 equal to 600. When we solve these two equations, we get the value of x1 and x2 as 150 and 300. Now we have to calculate the value of objective function at x1 equal to 150 and x2 equal to 300. So we get z is equal to 1650. Since the value of x1 and x2 both are positive and hence the solution is feasible. Now let x1 and s1 be the basic variable and hence x2 and s2 becomes the non-basic variables. Put x2 and s2 equal to 0 in the given constraints. We get two equations as x1 plus s1 equal to 450 and 2x1 equal to 600. When we solve these two equations, we get the value of x1 and s1 as 300 and 150. Now, we have to calculate the value of objective function at x1 is equal to 300 and s1 equal to 150. So we get z is equal to 900. Since x1 and s1 both are positive and hence the solution is feasible. Now consider x1 and x2 as basic variable and hence x2 and s1 becomes the non-basic variable. When we put x2 and s1 equal to 0 in the given constraints, we get x1 equal to 450 and s2 equal to minus 300. Since one of the value lies in negative coordinate, which is contradicting the given non-negativity condition, and hence these solutions are considered as infeasible and they are dropped from further consideration. Let's take x2 and s1 as basic variable and hence x1 and s2 become the non-basic variable. When we put non-basic variables equal to 0 in the given equation, we get the value of basic variables which we get as x2 equal to 600 and s1 equal to minus 150. Since one of the value is negative, these solutions are infeasible and they are dropped from further consideration. Take x2 and s2 as basic variable. Hence, x1 and s1 become the non-basic variable. When we put non-basic variable equal to 0, we get the value of x2 as 450 and s2 as 150. Now, to calculate the value of objective function, put x2 equal to 450 and s2 equal to 150 in the given objective function. So we get z is equal to 1800. Since both x2 and s2 lies in positive coordinate, the solution is feasible. Let s1 and s2 be the basic variable and hence x1 and x2 become the non-basic variable. When we put x1 and x2 equal to 0 in the given equations, we get s1 equal to 450 and s2 equal to 600. Now, to calculate the value of objective function, put s1 and s2 in the given objective function and hence we get z is equal to 0. Since both s1 and s2 are positive, the solution is feasible. So the maximum value is 1800, which is obtained at x2 equal to 450 and s2 equal to 150. Hence, we can conclude that the optimal solution is obtained at x1 equal to 0 and x2 equal to 450 and z max equal to 1800. So that's it. Thank you for watching. Don't forget to subscribe the channel.